Welcome back to another video. What happened to the guy who lost his whole left side? He's all right now. Okay, let's go. We're talking about graphs with asymptotes. There's two main graphs that we're going to talk about. One of them is an exponential. The other one is a hyperbola. First of all, what is an asymptote? It is simply a line that a function approaches, but it never reaches. Okay, I'll show you what they look like. Now, with an exponential, remember that an exponential graph just means x is your power. They kind of look like that kind of exponential growth. Now, the way it could look is it could look all different shapes and forms. These are all different ways that we could talk about an exponential, but the idea is in all of those, x is your power. Okay, now before we go on, I just want to make sure that everyone is all good with their indices. This is mainly for my class at St. Clair's Catholic High. 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0 is, hopefully anything to the power of 0 is 1. Hopefully you remember that. Now 2 to the negative 1. A lot of my people have been saying negative 2. It is not negative 2. It is actually 1 on 2. And 2 to the negative 2 is 1 on 4. So just remember that anything to the power of 0 is 1. And whenever you take a power, generally you don't treat it like a multiply. It doesn't necessarily make things negative. Okay. Now that's going to help because we're going to take a look here. If I have the main transformations of an exponential is if I have, let's talk about y equals, I like to use the letter E. That's going to look like this. Okay, it's going to cut at 1. If I have y equals to the negative version of e to the x, guess what? That's going to look down this way, and I should make it a different color, shouldn't I? So let's do that in blue. And magic. Okay, the other thing that could happen is I could have y equals to, do I pick 4 different colors? Why not? I could have y equals e to the negative x. Now what that happens is it's just going to flip the way that the curve goes. It's going to go from large to small. Okay, and so if it's the other one, if it's the other way around, it's going to be y equals to negative e to the negative x. Those are the main kind of transformations. A negative out the front flips it on the bottom. A negative in the power kind of flips the direction that the exponential goes. Okay, and you can have a mix of both. Now, when we get to actually talking about this, you can see that in both of these ones, we have an asymptote of basically y cannot equal 0. Okay, same thing. Note how there's a line here in the middle that our functions both approach, but they never reach. They get closer and closer, but they never actually reach there. That's what we call our asymptote. And we can call it y can't equal 0. We can call the asymptote itself y equals 0 because it's the horizontal line there. I just normally like to think of it as whatever it can't equal, that's where your asymptote goes. Okay. Now, when we want to find the y-intercepts, we let what? X equals 0. And all we need to know is find the y-intercept, find the sign, so if it's positive or negative and which way, and the direction that it goes, and we should be fine. So if I want to sketch, let's try sketch a couple of these ones here. Let's start here. Y equals to the negative 4 to the x. So that's going to be the x-intercept here. If I let x equal to 0, sorry, y-intercept. So y-intercept, I let x equal 0, it'll be minus 4 to the power of 0. That'll just be negative 1. So because I remember a negative power will kind of go this way, it's just going to go down that way. And I'm going to cut at negative 1. Done. Move on to the next one. If I have y equals to e to the x minus 1, what I'll need to do here is I'll need to, how do I find my y-intercept? I let x equals 0. So I'll have y equals e to the negative 1. And so that'll actually still be a positive number, but it's actually going to be 1 on E. So I'm going to draw a line in blue. It's going to go up this way, but instead of cutting at 1, it's going to cut on 1 on E. Okay. And if I take a look at this one, I've got y equals e to the 2x minus 1. So I normally would look like this. And this is where the magic of the iPad kind of helps. Again, I'll use blue to be consistent. Now, normally my exponential would go like this. But this minus 1 has changed my y-intercept. It actually brings it down just a little bit. So it moves the whole thing down 1 because of that minus 1. And so now I can see that it cuts at this point here 0. And it also has a new asymptote. It's never going to reach y equals to -1. So that there would be how I sketch it. And this last one here, this is a trick one that only came up kind of not often. But if the number that you're raising a power to is less than 1, okay, so 0.8 is less than 1. If you put that in your calculator, you'll actually find that it goes through this way. Still cuts at 1, but any number that's less than positive or -1, it'll go the opposite direction in which you think. Worst comes to worst, use a calculator and use a table of values. Okay, just note that the bigger the power of x, the smaller your number actually gets. Okay, so you can kind of see that this trend will happen. Okay, hyperbolas. This is the other one. It's either these blue ones here. So this blue one here being y equal to 1 on x, or these red ones here, which is y equals -1 on x. Basically, these graphs have 2 asymptotes. The ones up here, they only had 1. Now, a lot of them you couldn't see because they were actually the y-intercepts, but if I dot these in, you can see that each of these had 1 asymptote. Okay. But when we get to these ones here, they have 2 asymptotes. Basically, you have one horizontal, which is a y equals something, and one vertical, which is an x equals something. Okay, so if you can take a look, I'll do it in green. There's a vertical asymptote here, which is an x equals, and there is a horizontal one, which is y equals. Okay, now the form is an fx equals to 1 on x, where basically if you ever see an x on a denominator, it will be a hyperbola. Okay, so if I have y equals 1 on x, it's going to look like this guy, like we talked about before. And it's going to look like this guy there. If it was negative, as we talked about briefly before, it's just going to end up in the other 2 quadrants of our graph. Now, try your best to not do what I did. Try to draw them so they kind of approach, but they don't ever really touch the axes. Okay. Those are your general transformations, and then we will also look at how we move left, right, up, and down. Okay, now for these hyperbolas, the best way to sketch these out is to actually use the domain and range. They help us to find our asymptotes. So if I'm looking at this one here, let's talk about my domain and range. So if I'm talking about domain for this guy, I'm talking about the x values, and I notice x is at the bottom of a fraction. That means x cannot equal to 0. There's my asymptote. And for the range, I also notice that there's a 2 up top. And so I know my y value, this whole fraction will never equal 0. So in other words, x will never equal to 0. So those 2 actually become my asymptotes. There's x equals 0. And there's my y equals 0. And I've got a positive one, so I know it's just going to be up this way and down that way. And that's would be plenty for a sketch. If I had y equals to 3 on x minus 1, now we start to see things a little bit differently. Let's do the same process though. Let's find domain. Domain would be, we remember that your fraction, your denominator could never equal 0. So that means x can never equal, in this case, 1. And again, looking at my range, I'm talking about the whole fraction now because it's talking about the y. This here will never equal to 0. Because my whole fraction here, that will never equal 0. And so now I sketch in these ones. I've got x can't equal to 1, so I'm going to dot that. There's my first asymptote. And the other one is y equals 0. And there you go. And I'm looking here. This is a positive. There's the x here. Also, I'm just looking at the x. That x itself is positive. So I know that my hyperbola is positive, which means it must be in the top right quadrant and the bottom left. And that's it. There's my sketch. Let's try another 2. What if I have some negatives? What if I start moving things around? Let's practice. So here I've got, let's do domain first. So for this one here, for C, my domain is I'm looking at the x's, and I know here that my denominator cannot equal 0, so I can see that x cannot equal to -1. So if x can't equal to -1, there's my domain. If I'm looking at my range, again, not pretty boring. My whole fraction cannot equal to 0. So looking here, let's dot those in. I'm going to have x equals to -1. There's 1. Okay. And y cannot equal to 0, so I'm going to dot that in. And now I'm going to be careful here because I can see that it is a negative, it's a negative hyperbola. So instead of being in the top right and bottom left, I'm going to switch to the others, which will be the top left and the bottom right. That's it. Move on to the next one. Now this one here is the only one that I think, the only example I've given where you change both. Let's take a look at domain, still talking about the bottom of my fraction. I can see here that my denominator cannot equal 0. So I know that x cannot equal to -3. What that means for my range is now this fraction will never equal 0. So that means y will actually never equal to -1. Okay, y will never equal to -1. So these become my asymptotes. X equals to -3, and I'm just going to pretend -3 is here. I'm going to dot that in. There's my asymptote. Y can't equal to -1, so I'm going to dot that in. Oops, not 1, -1. Okay, so those become my new asymptotes. And again, I notice that we have a negative hyperbola, so I'm going to be in the top left and the bottom right. And for the most part, all these questions are the same. Find the domain, find the range, dot in your asymptotes, sketch your hyperbola. Okay, looks like I've got one more here. And this is just to show you that these don't take too long. Domain here, looking at my denominator, x cannot equal to -2. And looking at this for my range, I can see here that y cannot equal to +2 because this fraction will never equal 0. Therefore, y will never equal to 2. Okay, and so I'm going to dot these in. X equals to -2 would be here. And y equals to 2 would be up there. And we're definitely dealing with a positive parabola, or sorry, hyperbola. So I'm going to be in the top right, bottom left. And there's my hyperbola transformed. Okay, now there's one more thing. I'm going to touch on this in class, but it's direct and inverse proportionality or variation. It's just the application of hyperbolas and straight lines. Okay, if we're talking about direct variation, I need you to be thinking, what type of graph is this? What type of graph will it give us? X is just a singular power, so we know that this is actually linear. Okay, or in other words, some sort of a straight line. Now, inverse variation is given by y equals to k over x, and this k is just, I should know what that is. So k is just the proportionality constant or a factor. Okay, And so all that means is it tells you how they relate to each other. Now, inverse variation, you should be thinking here, okay, look, that x is on the bottom. So this one here is actually a hyperbola. So it's going to be, you know, one of those types of graphs. Okay. Now, if I times both sides by x, that's how I would move the x over to this side. You can see the equation as xy equals to k. But most times you'll see it as y equals to some number on top of x. That's how you know it's an inverse variation. Okay. Now this question here, I'm going to do in class. So here's a good example of how they would apply the hyperbola in a real life kind of context. So he says here volume varies inversely with the distance from the speaker. Find the equation that represents the relationship between volume and distance from the speaker. If the volume is 100 decimals at 20 meters distance, find the proportionality constant. Using the found proportionality, find volume at 40 meters or find the distance where the volume is 10 dB. Okay, so this is an example of a practical question. If you want, pause the video, give it a try before class, see how you go. Okay, that is it. I'll catch you guys later and bye-bye.